Friends, the technology which we are going to talk today is known as heat pumps. So, what are heat pumps? We need not confuse it with the water pump. Water pump basically pumps the water from a lower head to a higher head. Heat pumps are similar in the sense that they do pump the heat, but they are not pumping the water. So, one of my friends, he said that heat pumps are basically pumping hot water. So that is not the understanding of a heat pump. So mind well, heat pump is not something which is pumping hot water. It is a technology which is altogether different. Now, what is this technology of heat pump? Heat pump, as the name indicates, would pump the heat from a lower temperature reservoir to a higher temperature reservoir. So, suppose we indicate the lower temperature reservoir by TL and a higher temperature reservoir by TH, then what the heat pump does is, suppose this is called the heat pump. So, this heat pump, HP I would say, would pump the heat from a lower temperature QL to a higher temperature TH, and for that we need to supply some electricity. Now, why this sort of application is required? So heat pumps basically they have a common application like if you want to heat the room or heat water, then this technology could be fruitfully used. There are some other applications also, but we would basically talk about these two applications, like if you want to heat the room and if you want to heat the water. Now there are alternate ways of heating the room. For heating the room you can employ an electric heater, but heat pump is more efficient. Now why is it more efficient? The reason is the heat pump, now suppose this is the space to be heated, and if you employ a heat pump, so what we do is that we supply to this machine electricity, and what would this machine do? This machine would take the heat from the surroundings, from the outside surroundings or ambient, and it would pump the heat to this space, right? So this is what the heat pump does, and the performance of this machine captured by coefficient of performance is equal to this heating effect, that is how much you want to heat this room, upon the supplied power, right? Now this is generally greater than 1. This is always greater than 1, okay? And because this is greater than 1, it means that suppose you are supplying 1 unit or 1 kilowatt of, let us say, electrical power, then in this machine, because this is greater than 1, this QH would be greater than 1 kilowatt. Generally, for the climatic conditions which we live in, we can have a coefficient of performance equal to 3 or 4. So 3 to 4. It means that suppose you are employing a heat pump and you are supplying 1 kilowatt of electrical power, you will get the heating equivalent of 3 kilowatt thermal. Okay. So if you compare this with the electrical heater, what in the electrical heater you are supplying 1 kilowatt electrical, and at the most you can get 1 kilowatt thermal. So this heat pump technology is thrice efficient, so 3 or 4 times efficient than the electrical heater, and because it is efficient, it is going to save lot of electricity, right? Similarly, for water heating we can employ this. Now in water heating, instead of this room to be cooled, you would have water, and this water is heated, okay? So that would be your application of water heating. Now when you talk about air source heat pump means you are basically taking the heat from the space which is the surroundings, right? And there is something called as ground source heat pump, in which you are basically taking the heat from the underground. Okay, so air source heat pump, right? We are taking the outdoor air heat, which is generally cold. So this surrounding is cold, but you are taking out the energy, and that energy from the cold space is supplied to a higher temperature, right? You must appreciate that we are taking the energy from the colder space. Now, why is this possible? Why can we extract the heat from a colder space? This is because we are supplying electricity. Now, this machine of or heat pump is basically a vapor compression refrigeration system. So you have a compressor here, right? You have a condenser here to release the heat, and you have an evaporator where the heat is absorbed. So this machine is similar to your refrigerator, where you have two heat exchangers. The condenser is the place where you are getting the desired effect or heating effect, and the evaporator is the place which is located in the surroundings or ambient, which is going to extract the heat QL. And how is this possible? This is possible by employing a compressor and an expansion device. So the refrigerant would flow, it would absorb the heat from the space in the evaporator. This refrigerant would be compressed in the compressor. This compressed refrigerant would go to the condenser. It would reject the heat to the space to be heated, and this condensed refrigerant is expanded back to the evaporator pressure. So this is a two pressure system which I am talking about. So similar to your air conditioner or similar to your refrigerator, the heat pump has two heat exchangers, evaporator and condenser, and two devices to change the pressure, the compressor and an expansion device. As I already mentioned, this has a very good efficiency, or coefficient of performance is 4 or 3 to 4, and this gives you 4 times the energy. So 1 kilowatt of electricity gives you 4 kWh of heating effect. Okay, so this is what heat pumps are widely used. Okay, so in the next video I will discuss more about the heat pumps. Bye for now.